Hello. Our project was rheology, which is the study of flow and deformation. I'm Alex Lagarda.
I'm Yuya Shimizu.
I'm Yota Morimoto.
Now, I explain about the Cavendish laboratory. We have learned about Cavendish lab in biology class at the school. Plus, Watson and Crick is printed in a Japanese textbook. The Cavendish laboratory has an extraordinary history of discovery and innovation in physics since its opening in 1874. This is old Cavendish. And this is now. Joseph John Thomson is credited with discovering electrons and isotopes and inventing the mass spectrometer. As you know, Ernest Rutherford was a New Zealand-born British chemist and physicist who became known as the father of nuclear physics. James Chadwick was an English Nobel laureate in physics, awarded for his discovery of the neutron. Crick and Watson were the two co-discoverers of the structure of DNA in 1953.
Okay, as I said earlier, rheology is about flow and deformation. This occurs with materials, whether they be fluids or solids. Rheology looks at flow and deformation. Flow happens with liquids due to some external force, for example, gravity or the river flowing down a stream. And deformation, which is the changing of an object's shape because of some external force applied. This is an illustration of flow and deformation. In the Cavendish laboratory, we used a rheometer to measure the viscosity and elasticity of agarose, which in Japanese is kanten. It's a jelly-like substance, and it exhibits properties of both solids and liquids. We also found that in water, it gels at around 38 degrees Celsius. This is us with a rheometer. We then used computer software to calculate the solid and liquid moduli of the agarose. The solid modulus is a measure of how elastic the material is, and the liquid modulus is a measure of its viscosity. The modulus is equal to stress divided by strain. This is the graph that we produced. The different colors are different concentrations of agarose. Higher concentrations gelled at higher temperatures. We can see the gelation point is where the storage and loss modulus, by the way, the loss modulus is just the liquid modulus, and the storage modulus is the solid modulus. At high temperatures, the agarose was liquid, mostly liquid, so the loss modulus was higher than the storage modulus. At around 38 degrees Celsius, they intersected, and the storage modulus would become higher, as we can see, and that is when it has become more solid. It is gelated. This is my name written in agarose. We also performed some micro-rheology. Micro-rheology is the study of rheology in microscopic structures, such as colloids, which are small solid particles within a liquid, for example, sand mixed in water. In the Cavendish laboratory, we used a laser tweezer, which is a focused infrared laser, in order to trap colloids, which were silica particles, in agarose at different temperatures and concentrations. We have a couple of videos for this. This video shows Brownian motion. That is a colloid. I believe it's in water. It's vibrating like that because it's being hit by tiny particles, tiny molecules of water. The colloid is much larger than the water, but there are so many particles hitting it that it exhibits this vibration. This is a video of manipulation of two colloids with the infrared laser. The laser is able to trap several colloids at a time, as it is quite powerful. Here we use time sharing of the laser to manipulate multiple colloids at a time. That means that the laser was firing many times every second. Yes, so we were able to observe the vibrations of the colloids in the agarose due to Brownian motion, and we found that the more concentrated agarose, the more viscous agarose, showed less vibration, and at higher temperatures there was more vibration due to Brownian motion, and it was easier to move the colloids with the laser.
Now I look back upon this week. Through this science workshop, we could enjoy doing experiments about scientific things we had not known at all before. This experiment is very different from that of Japan. In that, speaking English and using high-performance tools, we had a series of surprising events. Moreover, we could make a lot of friends, of course, Japanese and British students. At the beginning, I was very worried about whether getting along with UK students or not. But soon, this feeling was disappeared because they spoke to us a lot, in spite of Japanese badly pronunciation. And then I learned many things which is different from them. For example, as you know, people in England use knife and fork, but Japanese usually do chopstick. And also, the room of UK students are always clean. In my room, my roommate's side is very neat, but on the other hand, my side is very messy. But this is an exaggeration. And the surprising thing is some of UK students can speak Japanese very fluently. Anyway, we could enjoy Cambridge life with people in England. And I want to say Taiki and Sarah, our project teachers, taught us pleasure of science very kindly. So I really appreciate all your help. Thank you. That's all. Thank you very much.